Okay, cool. So, welcome everybody. Everybody to the hopefully the last but not the least session of the day by myself. So my name is Ilkka Turunen, and I'm a solutions architect for a company called Sonatype, which a lot of you guys, based on what we were talking about today, have heard of previously. So Sonatype is a company that hosts the central repository for Maven, and we were actually co-founded by the two original creators of Maven. We deal with software supply chain management solutions, and as a part of my job, I see a lot on how people tend to use build tools and third-party dependencies and other things in their software every single day, and how people build software. So when I heard that Devoxx was looking for talks, I thought I'd really want to share with you some views and some insights on how on what are the pitfalls of when it comes to creating software, and what are kind of things that are missing from the current software development pipeline and the current software development model. So this talk is really about figuring out, showing you kind of case by case what can be done to improve your DevOps pipeline and your DevOps model, and create software in a more safe and secure fashion, and take away some inherent risk that you have in your software that you might have not even been aware of. So with that in mind, let's dive into the talk, shall we? So to me, I mean, it's important to notice that software is now the defining factor in every single business on earth. Mark Anderson said quite famously in 2011 that software is eating the world. But if you think from a less optimistic point of view, you might even say software is infecting the world. I don't think that there is any business on earth that can be seen to be not a software company. Every business on earth today is completely dependent on software in one way or another, and whether or not they realize themselves or another. I'd even go so far as to say software today, every company is a software company today. The pessimistic view of this, unfortunately, is that when software becomes more prevalent and gets put into more things, it also moves closer to even human life. So for me, as a security-oriented developer, when this kind of phenomena started making the prevalence of software really, really scary. So this is a screen cap from Wired magazine. I put a link at the end of the presentation so you can go read it out yourselves. But a bunch of hackers used a known exploit in the infotainment system of a Jeep car by basically bypassing the Bluetooth verification of, you know, when you get into a car and you hook it up with Bluetooth, your cell phone with Bluetooth on the car. They managed to exploit that and actually compromise the entire car and control it whilst the guy was driving on a highway. Now imagine what they did in that video, in that article, is they actually killed his engine when he's on the highway. So imagine that this is the kind of world we live now today in. Software has become so close to us that it can have unforeseen implications if you don't design it in the right way, especially when we start putting it into places where we haven't previously done so. Well, another key thing, a key phenomenon that has happened with the prevalence of software is that as software has become the competitive differentiator for all companies, there have been many movements that aim to improve the ability for your company to deploy software. And things like open source have really helped us move forward and produce more software and produce more value without actually implementing everything ourselves. Things like DevOps have brought developer teams and operator teams together, and today, software as a business is really about the need for speed. It's really about delivering more features, complete features faster. Different microphone, okay. Here we go. So now I'm double microphone, so I hope, you know, things are starting to get a little bit louder. right? You guys can hear it from the back as well? Awesome, awesome. Can you just ramp up the bass so we'll hear a nice rumbling from, all right. So, as I was saying, software is really now, if it is the defining factor of all businesses and everything relies on software, then the best way to stand out and be ahead of your competitors is to deliver more software faster and better before. Things like DevOps have done a marvelous thing in bringing together people from multiple different fields such as operations and development and bringing them working in the same cycle as opposed to one another. Like today we saw in the very first keynote in the morning, you don't want people tossing their applications over the fence and saying it's an ops problem now. What you want to do instead is bring people together so that they can operate things and produce new value, new features faster as well. Because in the end, if software is your defining feature, then more features is more money, is more revenue. And that's really what most companies now push us developers to do as well. But with all of these phenomena, especially Agile and Lean, DevOps and continuous delivery, there are still some things that they do not address. To me, when I started thinking about this, when I was creating this talk, I thought that, as I speak to customers and my colleagues around the world, there are always three things that people tend to highlight to me. The first thing is something that you guys might find interesting. It's the prevalence, the presence of third-party code in our own software. The second thing is things when they go out of sight, they go out of mind. And finally, the conflicting motivations of everybody else in your company as opposed to you as a software delivery person. So let's explore what these things mean. So first of all, prevalence of third parties. Well, when I say third parties, what I mean is within your application, you have third-party code in it, most likely that participates in building your functionality, participates in providing a very, very valuable piece of your actual application's purpose, but it is not necessarily out there in the limelight, and you might not even think about it. I like this picture because it's from Scrubs. I don't know if anyone's a fan, but janitor was always a force who was in the background, kind of menacingly pushing JD, who was the protagonist, forward in the series. Sometimes even maliciously, but in the end he was good at heart. So, you actually have a lot of these janitors in your applications today. And how, you may ask? Well, the answer is in the form of open source components, libraries, dependencies, and other things like maybe an Oracle JVM, maybe other third-party code that you integrate as a part of your own code. Open source, I mean, it's a wonderful thing. 90% of today's servers run on Linux. Open source has helped us create many different functionalities and share them across the world. A guy in California can provide an algorithm that you guys can use over here within seconds of him publishing a button, right? So open source is really great, and as an industry, we've come to rely on open source on a very, very great deal amount. So as custodians of Maven Central, as custodians of the central library for Maven components, we asked ourselves within Sonatype, how prominent is open source usage? We obviously see a lot of traffic coming in, people downloading their Maven dependencies from the central repository, but we ask ourselves, how much of a common application today is open source? Any guesses? How much of a final bulk of an application is comprised of not your own code? 8%. How much? 8%. 8%. Any other guesses? 5. The OSGI guy, come on. Any other guesses? All right, 8 and 5%. Well, the fact of the matter is, in an average application, based on an analysis of about 1,100 applications for a report that's over here, it turns out that about 90% of the final bulk of the application the final, amount of code that's in the application, is actually comprised of open source and other third-party components. And only about 10% is actually the code that you write yourself. So only about 10% ends up being your own stuff, and in fact, building an application resembles more like assembling and sourcing code rather than building it from scratch. That, to me, when I first read it, is quite a shocking number. But
also, we have to ask to ourselves that how many percentage of that open source code that we are using? We only 5% of the 90% of code we are using.
That is, of course, a very, very good point and a good comment. So that's actually a very good question. How does that number end up looking like that? Because on the face of it, if you look at your dependencies, let's say you scrutinize your pom.xml and you start reading it, what might come out is, I've only got 5 libraries in here. I've only got 5 dependencies. But there is a concept called transitive dependencies. And what that means is, very simply put, you rely on open source codes to provide some functionality, and you rely on third-party components to provide some functionality for your applications. But it turns out the people that you source from also rely on other open source and third-party components. So projects tend to actually have their own dependencies. Those dependencies tend to have yet their own dependencies. This chain of dependencies is called the transitive dependency chain. And on the face of it, you might think, okay, well, that doesn't sound too bad. But if you think about the network effect and, into your college year math classes, you can see that you can think that this can actually get really complicated really fast. So what we did was we took all of the components that are housed in Maven Central, and we asked the question, how many components are dependent on each other? And we just ran a visualization that linked every component's dependencies with one another. So the picture that you see behind me is not just some nice little graphic dust mite that is floating in the air. That's all of the components housed in Maven Central in the summer of 2015, so about a year ago. Now obviously the dust mite has grown bigger. And all of these orange lines that you see here are actually those components related to interdependencies with one another. So, as you can see, this problem can actually end up being quite complicated very, very fast. And when we looked at this, we weren't actually the only people that had thought about this, using open source components within, or using third-party components within our applications. For example, there's this small working group called the Open Web Application Security Group that publishes, at least that some of you guys might even read, the OWASP Top 10. Anyone not aware of it? No? Everybody's read it? Good. There's one guy in the back, the OSGI guy again, trolling away, I see. So in the 2013 edition, so these guys published the top 10 list, and everybody always remembers it's from don't have XSS vulnerabilities and don't have SQL injection vulnerabilities. But a new item added to the OWASP top 10 in the last time around was the item A9. So on the top 10, the top 9 bits was using components with known vulnerabilities. Now, what this means is when you source components, even if you source your first-hand components well and you try and make sure that you're not using directly some of the code, what ends up happening is the transitive dependencies and other bits that end up making their way into your application as a part of your supply chain might actually have some problems. So what they say is the specific risk for one individual component that gets bundled up into your application is relatively small. I mean, exploitability is medium at best. And most vulnerabilities that we know of in open source components tend to be small buffer overflow things. But you only need to have something that's multiplied by many times. So the problem is it's very, very widespread. So according to the OWASP Alliance, as we do this, resolve this transitive dependency debt, and as we land on a final application, it actually ends up being quite a lot of components that make their way into that application. So widespread prevalence can mean that even an average exploitability problem can become a big problem if you know all the numbers align just in the right way. In this case, for example, what happened in the cheap case was that it was actually a vulnerable third-party component, an open source component within the infotainment system that provided that access point for people to flow. And if you think about it from a computer attacker's point of view, would you rather try and figure out a custom vulnerability in someone's own code, or would you just source one of the millions of components that are already out there, figure out something that has a vulnerable version in it, and just try everything to see whether or not something cracks based on that easily exploitable thing? Therein lies the risk, and that's why the OWASP Alliance chose to actually include this as a part of their list. So the next question to ask is, okay, if this is prevalent, how many components end up on average into your application? You know, what happens when we bundle code and we resolve these dependencies into our own application? So again, we went back to the data and we came up with the understanding that the average company, you know, hereby illustrated the average company incorporated, downloads on a yearly basis about 240,000 times. You know, remember that this is a mixture of large companies, small companies, so obviously mileage will vary between different users of third-party components. And this probably, this is reflective of Maven Central, but probably gives you an idea of how it looks like in any other ecosystem and any other language system as well. Now, what's slightly worrying is that 6.4% on average that a company downloads from Maven Central are versions that are known to be vulnerable. So they're dependencies that have known risks a la the OWASP A9 recommendation. And they have been downloaded into the companies every single time. So the average number ends up being about 6.5% if you look at an individual company. And that usually translates with this volume, means that there's about 15,000 components that end up making 15,000 downloads that end up making it into one build or another. Now, looking a little bit deeper into this number, we notice that actually over half of the vulnerabilities in this 6%, so 6% isn't that much, but again, over half of the vulnerabilities in this list are actually older than 3 years. So over half of the vulnerabilities that were downloaded were actually reported over 3 years ago, and in most cases there were patches that were released for this specific vulnerability as well. So the question is, why would people do that? And well, we heard the answer earlier on before.
It's laziness.
It might be, but again, we've heard the answer before. It's not that people don't care, it's that it's actually quite hard to be able to pick out these different things from your applications, combined with the lack of visibility of, you know, what are vulnerable versions, and combined with the lack of understanding of what is actually getting bundled into your final application. And I'm coming back to the point of when things like Heartbleed or, you know, Commons collections or the Zaylan vulnerabilities or the Struts vulnerabilities end up making their way into your applications. To me personally, when they end up then in really important things, that's when this scenario becomes really, really scary. It's one thing to have a website where, you know, someone might be able to cross-site scripts a form or something like this. But it's another thing when these vulnerable components, through lack of visibility, laziness, or other vices, end up making themselves into your final product. So that's the first thing. The prevalence of third-party components and our continued reliability on them. Now, the second problem is what I call out of sight or out of mind. So if we end up having 100 components that are bundled into our application, we end up having a lot of different bits and pieces that end up in the final code, then as we build from individual dependencies into applications, And from applications, we deploy into containers. And from containers, we build a series of services, data centers, microservices using the OSGI logic, all of these things. What can happen is only one single-threaded jar file here can end up implicating an entire system. And as we move on from one level of abstraction to another, the processes that bundle in applications tend to also obscure what ended up going inside. If you ever try to look into a Docker container, for example, into what exactly is in there, you pretty much have to jump in, execute a file list command, get fingerprints out. It's a long, and arduous and actually surprisingly complex process. The same thing happens on the container and the application level. And what can happen, and what most often happens, is the information system gets compromised, and a long path of remediation starts. So I asked myself the question, how long does it take to fix a problem, at what stage? So if you find something out, when it's already deployed into production, when it's already deployed into, a live system and someone manages to crack it, the amount of time units, this is based on a conference journal, is about 250 units of time. These are just there for scale, so they're not really like minutes or days or anything. Just 250 units, right? Now, if you go a little bit earlier and you do your due diligence and you manage to test your application and pick that vulnerability up, you're in a much better place. You can actually get the vulnerability sorted in about 50 units of time instead. And even better, if you only when you're building your application you manage to remediate it, it takes about 25 units of time. So as you can see, if we pick vulnerabilities or big issues up at this point, it's much faster to remediate, 10 times faster to remediate than it would be in the final production system when you've actually deployed it in there. Well, that in itself is not news. But the truth is, if 90% of our applications are actually dependencies, and 10% of the stuff that you do here 10% of the code that you do ends up here, then the question is, what is the time to remediate those known vulnerabilities? And that's much shorter than even remediating on your code level, because what you just need to do is you need to pick out the bad ones from the bunch and make sure you're not using them. And as someone coming from a company that curates the largest library of open source on the internet, it's a strong statement. Don't use everything available for you. So, final thing we did was we analyzed 1,500 different applications to just see, on average, how many components end up in there. And based on that report, usually an average application will have about 106 components, 24 known vulnerabilities, and generally speaking, 9 different restricted licenses. When I say restricted licenses, that means things like copyleft licenses, AGPL clauses. They don't necessarily mean, it's a vulnerability or it's something that's bad. It just means you have to consider the code re-release and distribution clauses of using those dependencies. And combined with the transitive dependency problem, you might have these restricted licenses actually as a result of your transitive dependency chain, not necessarily something that you pick yourself. But if you bundle it into a final application and you distribute it, from a legal perspective, that does not matter. You're still implicated by the legal restrictions of that framework. It's no different on the Docker container level either. I mean, this problem isn't necessarily a Java problem or a language problem or any other type of problem. It's actually a phenomena of engineering handiwork and craftsmanship. So if we look at Docker containers, there was a research company, Bunny and Ops, that did a little bit of analysis on the Docker Hub last year. And what they found out was that 36% of all containers in the Docker Hub contain known security vulnerabilities. So that's every single container in the Docker Hub has some security vulnerabilities in there. And actually highly classed security vulnerabilities. So anything above, levels of Heartbleed pretty much. Now, you might say, okay, some containers have been frozen in time, so, builds don't break if you rely on an old container, and that's a fair thing. So if you look at only images that were published in 2015, actually 40% of them have known high-class vulnerabilities. Again, the same criticism stands. You might not necessarily be implicated by having a component with a known vulnerability, but you should at least be aware of it. And finally, even if we look at just the latest images available on the Docker Hub, 23% of them still have known highly classed security vulnerabilities. So in every 5 containers that are published in the Docker Hub will contain something that has a known high security vulnerability. And of course, the way Docker works, you might bundle images, you might bundle layers. This transitive problem works out exactly the same as you build different environments. Well, we know that these risks exist, and we know that they're there, and either due to laziness or either due to happiness, most of these problems people aren't entirely unaware of them. But what is problematic is, in most companies, managing those vulnerabilities tends to go like this. This is a real story that one of my colleagues told me. So this article, has anyone seen it? You have. Well done, mate. This article was released last November. It was released after a presentation done last January in I think Silicon Valley in the RSA conference or Black Hat conference. And what that original presentation described was a vulnerability in the serialization mechanics of Java itself. So they created a tool called SOSYAL that allowed you to send a compromised serialized object into any Java application that would deserialize them. And if you did things just right and you had just the right classes in place, you could actually manage to gain system-level access from your Java application. So this security research firm took that allegation to the test and actually managed to find a vulnerability in the commons collections packages, all the way up to the latest commons collection package in the deserialization form, and they managed to compromise all of these different applications, including WebSphere and Jenkins. Now, my colleague told me the way they managed this vulnerability, I asked them, okay, you guys had this, what did you do? And he's like, well, truth be told, one of our guys found it on the internet and sent it to my guys and asked, do we have this? Well, he forwarded it to someone else. He replied to, I'm not sure about our application, but how about the other application, or the other application, or the other application? And pretty soon, that chain of emails went all the way up to the CTO, went all the way up to the directors of engineering, and what they realized is they had no clue whether or not their applications used this. The assumption is probably yes, but they were not actually sure. And that to them was a sobering moment. They realized that we have to think about something. The problem is, for example, if you look at the case Heartbleed, which was, the big thing in 2014. For every Heartbleed in 2014, there were 30 other vulnerabilities of equal or higher significance. So that means for every vulnerability that has a nice website and a logo and a bleeding heart logo, there were 30 other vulnerabilities that were actually disclosed. Some of them in Siemens systems, but to Siemens' very good honor, you guys fixed it very, very fast. So that's pretty cool. But the message here is for every Heartbleed, there are 30 other vulnerabilities that never get a website, that's kind of silently make themselves known and are ready for exploitation, right? So the final thing that stops things from happening, and here I'm going to talk about laziness, is okay, well, if we know that these things exist, and to be honest, I think everybody in here has always been aware that these risks exist in using open source. And using open source is not a bad thing at all. In fact, it helps us deliver more value faster. But one final thing that we have to do is we have to look at the motivations of all the people involved in creating software. First of all, If you look at what we as developers are most often incentivized to do, it's to deliver more software, more features, faster, hopefully on time, on budget, and finally with acceptable enough quality or risk. It's not, create the best piece of software out there. It's create something that will do the thing in an acceptable enough quality, hopefully on budget, but most preferably, we need to ship it by the end of the sprint. So do what you can. Yeah, the problem is the security guys are incentivized completely differently. So there are many companies that do have security guys, but those security guys, to me, in my own personal career, have always been more like this. The dudes that sit under the bridge, that the troll that sits under the bridge, and you and your developer buddies are trying to ship something into production, and just as the final few sprints start, the guy crawls out from the under the bridge and comes up with a security audit and says, "Okay, guys, here's actually all the things that you did wrong in your process. Go and fix them." So. What tends to happen is devs don't really appreciate, we as devs, I at least don't appreciate when a smarter than thou guy comes in and starts telling you, this is what's wrong, this is where it went wrong. But these guys obviously have good intentions. The security guys are actually motivated to make sure that, security vulnerabilities are addressed, and sometimes even through things like standards. So for example, if you do payment gateway systems, you have to comply with something like PCI DSS that says in its 6th requirement, establish a process to identify vulnerabilities, make sure that you categorize them as high, medium, or low, and make sure that all the software, system software are patched, and those patches are applied in a timely fashion. And if you don't pass that audit, you can't process payments. So sometimes the security trolls from under the bridge exist for a reason. They try and stop you from, putting something into production that might end up getting you sued in a court of law. Another example from another field is the IAC standard that's used in medical devices. So if you do a medical device, the corresponding security standard there says you have to account for all software of unknown or uncertain pedigree, which is most commonly, it's an umbrella term, but most commonly tends to apply to open source software. So when you use open source as a part of your systems, you have to do specific things like, for example, introduce scanning, introduce other processes as well. But the problem is there's a conflict of motivations here. Developers are incentivized to deliver faster, but now these security guys are actually incentivized to stop delivery on its tracks. So on the other hand, we're in this weird situation where we need to move faster and break things and apologize later. But on the other hand, if we don't stop and think, we're going to end up in a situation where it's a tug of war, where it's pretty much a knife fight between the security guys or the security team and the development teams, where one thing will lead to another, and usually in these cases shadow organizations tend to start popping out. People bring out their cell phones, they put on the hotspot, they download stuff from the internet, and never tell anyone until someone comes and tells you, what's this then? So another big anti-pattern here has always been that these things have happened manually. These audits are always rubber stamp processes. You've got a big checklist of things, and you comply to it or you don't, and it's a lot of paperwork for a lot of people involved in the development process that has nothing to do with delivering new value. It's just making sure that you've ticked all of the boxes. So that's actually a massive, massive anti-pattern, and it's a massive, massive undertaking to think that people would comply to that. So the conclusion that I have come, and a lot of people before me have come, is we shouldn't necessarily be talking just about DevOps or ops dev or something like this, or DevSecOps or any other movements like that. We should be talking about any ops. We should be talking about department ops. So the biggest problem I see today in the way we deliver software is that we don't take into consideration, we don't take into the actual value creation process people that exist outside of the immediate delivering and maintaining of the software, because there are other people like lawyers, like the security guys, that have to actually do their job. And some thinkers in the field actually came up with a quote a few years ago saying, "Security is dead. Long live rugged DevOps." Now, rugged DevOps is the answer of these two guys, Josh Corman and Gene Kim, to the idea of what DevOps is missing. So rugged DevOps came out as a movement called Rugged Software, and they came up with their own manifesto as a kind of answer to the Agile manifesto that ended up happening many years ago. You can find it on ruggedsoftware.org. It's quite a fun reading. But to me, the top pick of this quotation is that I recognize that my code will be attacked by very talented adversaries who are probably smarter than me, probably know a lot more than me, and probably have very bad intentions for my code. So what this movement advocates is, when you build your code, don't build it assuming that you can firewall it away. Build it assuming that there's going to be some little sneak that's going to come up with some kind of weird new trick that you can't even think. Another key thing is that my code will probably also be used in ways that I never imagined and I never intended for. Every one of us has probably gone through the process of just writing a small POC, and that is still in production 3 years later. I certainly have had a lot of my code end up like that, and that's not very fun to do. So what can we do? How can we become more rugged in our software creation? Now that we've identified these key 3 problems, how can we mitigate them? Well, Forrester released a very good study just a few years ago around this thing, and they said, well, actually last year, and in that study they said there are 7 key habits. They interviewed people like Jess Humble, Gene Kim, Josh Corman as well for this report, and they identified these 7 different habits, that you can do, and 7 different things that you can do to enhance your process to address these issues. So we'll walk through all of these very quickly to kind of give you an understanding. But the very first, element number 0, I think, is, first of all, take a deep breath before you do anything else and realize that it's a long process. Even small steps to remediate productivity is better than no steps. And everybody's on a journey. Everybody's always trying to improve. It's really about continuously improving the process, not trying to just put a tool in place and forgetting about it, because that's not how security works. You can't just tool it away. So first of all, the security guy from under the bridge needs to be pulled out from under the bridge or from the other office. The security guy needs to become a part of the DevOps team, a dedicated part of the same team that delivers the application. For every 2 developers, there should be 1 QA guy. For every 10 developers, 1 ops guy. For every team, at least 1 security guy. That's how I see it. So security expertise should be a normal part of estimating for a sprint, and should be a normal consideration for a sprint. It should not be something that happens as an afterthought or outside the delivery process. It should be dealt as everything else is, as a part of the delivery cycle. On the second point, assess the situation. Well, looking at some research on the field of information security, what is the best way to assess a situation? Well, the best thing to do, and the most impactful thing to do, according to Josh's research, is to actually build or buy defensible software. The analogy is quite simple. Would you rather, let's say the zombie apocalypse happens, World War Z starts. Would you rather be in a shed, in someone's backyard, made out of wood, or would you be in a castle, with bows and arrows and, cannons stuck in the side? I would have my pick, certainly. The second part we need to do is rely rapidly on automation. We cannot rely on human replication because humans are feeble in their nature. So first of all, you kind of have to figure out what automation exists to help you deliver that software faster. And then you have to say to yourself, it's quite small, isn't it, on this one, but you have to say that you have to only critically use the best parts and suppliers available to you. Secondly, you have to make sure that you cover all of your fields. You have to make sure that you cover all the different aspects of your delivery cycle, not just code quality, or not just making sure that you're using a good Docker container. You have to map out the entire field of the application. The third thing is once you've done that, once you've done this basic automation, you need to include intelligence about the components. You need to bring out things like security information. And finally, you need to take that information and actually automate it as a part of your normal delivery cycle. So, to automate things, we need to do incremental improvements. And the best way to do incremental improvements is not to get stuck into something like this, which is a PCI DSS 3.1 compliancy Excel, but rather take those individual items and take your normal tests, test suite that you write every single day for your application regardless, and include governance in that application test suite. The fourth point is you need to leverage your continuous integration pipeline as a key part of the security information. And to do that, you need to know what to use when. So there are two types of security tools in general, asynchronous and synchronous tools. Asynchronous tools are things that take a long time, require human expertise to read, and synchronous things are things that should be machine actionable. They're the basic test cases for your security. So first of all, synchronous tooling can be something like this. It can be tooling that plugs into your regular builds that takes the artifacts that you build and runs them through a dependency scan. There are free tools available. There are also commercial toolkits available for them. And it can come out with something like this. That's a report of, how many components are in the applications, how many components were actually identified in your applications. And they can also help you develop tests for those dependencies. Like, for example, if you cannot really see it on this screen, but if there are any known vulnerabilities for those issues, highlight them. Those tests can look something like this. And ideally, you should be able to run them even as a part of your build. So for every build that you do, you should be able to evaluate all of the dependencies, including the transitive stuff, and make sure that your tests are passing for known security vulnerabilities. So this should not be something that you do on your own. It should be something that gets passed out as a normal part of the build output. Of course, there is a need for more deeper coverage. Just looking at components and cross-matching it into a database is not always enough. At the end of the process, you still might need to do a comprehensive audit with human recycling, but that shouldn't happen necessarily every single time. Here's an example architecture of one of our companies that's a good friend of mine in Germany called CodeCentric. And they've developed a kind of rugged continuous integration pipeline by leveraging things like SonarQube and other analysis tools that you can actually run directly as a part of your Jenkins delivery jobs. It's a good place to start if you need some examples. Final thing to do is a good practice is to create something called a bill of materials. A bill of materials is a document that lists all of the dependencies that you have in your applications. So it can be a JSON, it can be something that looks a little bit more graphical, like the one I have over here. But what that bill of materials is good for is when there is that big email thread that goes out and says, are we implicated? Having this done for every build will allow you to search for them. So the only thing you need to do is Control F, Commons Collections 3.1. Oh, application A, B, C have Commons Collection 3.1. Now we know. It seems like an almost insignificantly small detail, but it is a very, very important thing to do, and it's a very easy thing to do as well. And according to some research published by a Verizon report last year, 97% of data breaches in the US were comprised of 10 different known vulnerabilities in their applications. And most of them actually, I think the oldest one is from 2001. So you've had 15 good years to fix that, and that still hasn't been fixed, or people haven't updated their dependencies. The final one that I want to say is standardize on third-party software. You have to be sure that what you're using in terms of dependencies, what you're using as frameworks, go through more audit than just looks like people like it on Stack Overflow. That's not enough. You should instead aim as a company to say, for example, we're only using JUnit as a test framework, we're only using the latest 2 versions of JUnit as a test framework. And for example, you shouldn't just accept any different project. You should take them through a rigorous analysis when thinking about what to use. Things like, for example, how is the security side of things going? Are the licensing issues good? But most importantly, for example, how long does it take on average for them to fix a bug? You know, if there is a bug, how long do these guys take to fix it? That's quite an important practice. And when that fails, things like NPM gates tend to happen, but we're running out a little bit of time, so we're not going to illustrate that too much. Talk to me about NPM gate later. It's quite a funny story. Final things that you can do to introduce this kind of stuff all the way up is you actually have a lot of audit trail already in your software development pipeline. Things like commit logs and other stuff. So you can leverage these. You can build tests on top of them to make sure that, you know, on the audit side of things, you can get information earlier on. And finally, the security guys have some really, really cool tools like Metasploit and other pen tools. You should use these also as a part of your own development pipeline. Metasploit, for example, is a very, very interesting little handy command line CLI tool. Allows you to run different exploits on applications, point it to your application, and just run a suite of exploits and see what you're vulnerable to. Very, very interesting stuff to see in action. You should use these tools and automate them, their usage, and actually make them a part of every single build. So for every build, you should ideally get a bulletin of what is the coverage of your dependencies, what is the coverage of your components, what is the status of your dependencies. So, and that information should not be hidden away. Like the Atlassian guy said in the morning, you should, you know, in fact, make that information as available as is possible, either through walls of shame, either through other places, but at least having a dashboard like a build monitor or whatever that shows you, you know, the status of the company today. You know, what's the worst application out there? What's the best application out there? So that way, because things are publicly known, they are also taken away and fixed, and they're not hidden away in a trench one way or the other. So this way, if you look at the original pyramid, DevOps can really help you actually cover most of the info security basics. They can really help you make your software more secure with relatively small steps without you even realizing it. So if you take these tips, you put them into place, I guarantee, just like we did in the bill of materials, you'll manage to stop a lot of these long email threads going around in your company, and you'll actually be able to focus on what's most important, which is using the software and creating more of it. So in summary, collaboration through transparency, Chuck Norris plugin approves, and you know, shifting left is better, it's cheaper, it's faster. You know, by bringing these tools as a part of the delivery cycle, you can fix them faster, and you know, the earlier you fix it, the cheaper it becomes. And maybe that way you can avoid what here has been a catastrophic chain reaction. All right, that's it for me, and that's it for today. So thank you very much, everybody, for listening, and let's make Vox Days a good conference next year as well. Here's my references if you want to find out more about these things that I reference in this presentation.